James Webb Telescope info about Betelgeuse's explosion shocked the industry. The Betelgeuse supernova is one of the astronomical events that is most eagerly awaited. A red supergiant star reaching the end of its existence, Betelgeuse is situated on the well-known shoulder of the Orion. Betelgeuse, one of the brightest stars in the sky, oddly started to dim in 2019. The fading was so pronounced that it was visible without sophisticated optics. Betelgeuse dimmed for a few months before watchers started to worry if the star had passed away. Even though the red giant star's brightness had returned to normal after a few months, scientists were astonished to detect evidence of the enormous dimming when they concentrated their most powerful telescopes on it. This star's life cycle is nearing to end, and it will explode. When might a supernova occur, and why? And will it result in catastrophe for Earth? Welcome back, everyone. In this video, we will be talking all about Betelgeuse's explosion. One of the most well-known stars in the sky is Betelgeuse, often referred to as the Alpha Oriana. It is the 7th brightest star visible from much of North America, Europe and Canada, and the 10th brightest star in the sky. Betelgeuse's actual distance from Earth is unknown. However, experts estimate its distance between 430 and 724 light-years. Betelgeuse is the brightest and nearest red supergiant star to Earth, to put it simply. There are only 200 red giant superstars that have been identified in the Milky Way. Betelgeuse is visible from a distance of 548 light-years, is 16 times the size of the Sun, and emits 1260 times as much light as the Sun. With a 3600 Kelvin surface temperature, it is colder than the Sun. Approximately 13% of Betelgeuse's total radiant energy is visible light. If we could see the light at all wavelengths, Betelgeuse would appear more brilliant than Sirius. Betelgeuse's diameter is calculated to be almost 764 times that of the Sun. Jupiter and the asteroids wouldn't be the only things the star would have an impact on if it replaced the Sun in our solar system. Earth, Mars, Mercury, and Venus would all be completely engulfed as a result of this. A nebula surrounds the red star Betelgeuse because the material is expelled unevenly from it in all directions, which causes the star to lose around one solar mass every 100 years. Betelgeuse is surrounded by a nebula, 250 times bigger than the star, and around 30 times the distance between the Sun and the Earth. A star's core is where the gravity-driven fusion of the hydrogen atoms produce helium in a nuclear explosion. Heat and light are two types of energy that are often and copiously released during the fusion process. This energy travels to the star's surface, eventually releasing it as a photon into space. The star will eventually run out of its primary fuel, hydrogen, and rely on the combustion of helium and carbon. Once all the helium has been used, iron will be produced when neon reacts with carbon. When this happens, the energy produced with neon and the iron fuse is absorbed. As iron starts to burn inside the star, its strong gravity leads it to collapse in on itself, resulting in a supernova explosion, one of nature's most powerful explosions, that can produce the equivalent of 10 billion suns. Star emits light at different temperatures and wavelengths, depending on their age and stage of evolution, producing a spectrum of hues from the blue of the youngest stars to the oldest red. The star's outer shell is thought to expand and contract over the cycle, generating variations in the star's average temperature and diameter. Betelgeuse attracted a lot of interest due to its unpredictable fading in 2019 and 2020, followed by a brief return to its typical brilliance. According to some astronomers, it might indicate that the star is dying. Betelgeuse has been extensively studied since the 1st century BCE. However, its abrupt and unusual decline is still a mystery. Betelgeuse is a pulsating star, therefore it varies over time. The star's optical emissions change color and disappear as one moves out from its center due to limb darkening. It's crucial to consider the circumstellar envelope, which is made up of material released from the star and emits and absorbs light when attempting to describe Betelgeuse's photosphere. Since the apparent size of the star varies with wavelength, and diameters might change by as much as 35% depending on the wavelength used to measure them within the electromagnetic spectrum, it isn't easy to compare observations directly. Betelgeuse's surface mass ejection ejected 400 billion times more mass than a typical coronal mass ejection. This explains why Betelgeuse started to dim rapidly in October 2019 and had lost about 3 times as much brightness by mid-February 2020, dropping from magnitude 5 to magnitude 17. Betelgeuse's brilliance had been remarkably consistent for over a week by February 17, 2020. On day 5, it seemed as though Betelgeuse had completely stopped dimming, essentially concluding the dimming event. Recent visual fading seemed to have little to do with the impending core collapse. since the infrared did not experience any significant alterations on February 24, 2020. Another study that was released that day came to the conclusion that the star's dimming was probably caused by large-grained circumstellar dust. The study excludes dust absorption as a significant factor using data at sub-millimeter wavelengths. Large star spots, however, seem to cause the fading. Betelgeuse's luminosity had increased significantly, which was clear from a closer inspection. Betelgeuse's brightness recently dropped significantly, and on August 30, 2020, a second dust cloud was discovered forming from the star. In June of last year, it was proposed that a cold region on the photosphere was the cause of the dust, and in August, a second independent investigation supported the first. The dust is thought to have been produced by the star's gas ejected when it cooled. Dust that obscured visibility may have resulted from a surface mass ejection. In 2022, millions of kilometers from the star's surface, material expelled from the star's surface cooled and compacted to produce the star's fading dust, according to the Hubble Space Telescope research. The star's photosphere was broken up and shot off into space and is several times as large as our moon, obstructing it from Earth. Even backyard astronomers could see the dimming, which began in late 2019 and lasted for a few months. Even more astounding is that 400 days later, the supergiant's pulse rate has stopped. To trace the cycle, astronomers have been observing Betelgeuse's surface motions and brightness changes for at least a century. The damage is a reflection of the explosion's power. A notion put on by astronomers may explain the disturbance. Additionally, being revitalized, the star's photosphere is growing stronger over time. The star's natural cycle is upset, causing the internal structure to vibrate like a shattered bell. The process by which red stars age and lose mass before their nuclear fusion furnaces run out and they erupt as supernova are now better understood thanks to these discoveries. How much mass they lose significantly impacts whatever happens to them. It's not always the case that a significant loss event heralds an impending explosion. Therefore, Betelgeuse's exceptionally malevolent behavior does not presage the star's quick ascent to prominence. According to experts, a huge star's surface mass ejection has never been found, indicating that there is something going on that we do not fully understand. The infrared radiation from the ejected material is still traveling away from the star and can be seen by NASA's James Webb Space Observatory. Betelgeuse's fading has finally stopped, and it might take once more rank as the 10th brightest star in the night sky. Despite being far away, Betelgeuse is one of the brightest stars in the sky, shining at a brilliance that is almost 100,000 times that of the Sun. Betelgeuse's quick fuel combustion is necessary to keep up with its tremendous energy output, hastening the star's demise. A stunning supernova will occur when the star runs out of fuel and falls beneath its weight. Then, for a few weeks to months, Betelgeuse will gradually get brighter until it may even reach full moon levels. Throughout the day, it will become clear. If so, when should be anticipated? Nobody can say for sure, but we probably won't see that happen in our lifetimes. It might occur today, or it might do so after a million years. Will the Betelgeuse explosion destroy Earth? Because Betelgeuse is so far from Earth, its explosion won't endanger or even significantly affect life as we know it. Betelgeuse is more than 10 times farther from us than the safest distance from a supernova for human life, which is 50 light-years. Instead, an extremely bright star will suddenly appear in the sky, giving everyone on Earth a display. That is all for this video. We will be back soon with another informative video. Don't forget to like and share this video. Until next time.